Hi, welcome back to Physical Science 2.3 Newton's Laws Part 2. Okay, so Newton's laws, remember, and you do need to try to memorize these. First law is an object in motion or rest will stay in motion or rest unless acted on by a net force. Second law is an object will accelerate in the direction that force is applied, and force is equal to mass times acceleration. And third law is for every action force, there's an equal and opposite reaction force. So let's review what those are. Law 1, an object in motion or rest will stay in motion or rest unless acted on by a net force. It is talking about an object. This does not have free will. Okay, it cannot move on its own. So this is not talking about a person unless you put the person in a vehicle that is moving. Okay, or it's at rest. This is the chair. It will not get up and move all by itself. So look at these little simulations. Once airborne, unless acted on by an unbalanced force, which is gravity and air friction, the ball would never stop. And that was actually proven in 1969 on the moon when Neil Armstrong hit a golf ball from the moon, and provided it didn't encounter anything else, it's still going. Also, unless acted on by an unbalanced force, the golf ball would sit there forever on the tee. It's plastic. It's not biodegradable. It's not going to go anywhere. Okay, unless there's an earthquake or the ground shifts or an animal walks by, it would sit there forever. So why then do we observe everyday objects in motion slowing down or becoming motionless without any force? And you already know the answer to this. It's friction, right? Friction is the force that we sometimes can't see. Objects on Earth, unlike the frictionless space the moon travels through, are always under the influence of friction. Friction is everywhere, so even though we play pretend that there is no friction, there's always friction on Earth. If you slide a book across the table, watch it slide to a rest, the book comes to rest because of the presence of a force, and that force being friction. Okay? In the absence of an external force, though, in the absence of that force of friction, the book would just continue to move in the same direction and speed forever, or at least till it hit the end of the table. Newton's first law and you. Don't let this be you. Always wear your seatbelt. Because of inertia, objects, including you, resist changes in their motion. So when the car going 80 miles an hour is stopped by a brick wall or tree or car in front of you, your body actually keeps moving. This is why, unless you are strapped down, you become an object in motion. Law 2, an object will accelerate in the direction that force is applied, and force is equal to mass times acceleration. So remember, Law 2 is F equals ma, right? This is our law that has math involved. Newton's law proves that different masses will accelerate to the Earth at the same rate, but with different forces. The force of a 10 kilogram rock and a 1 kilogram rock are not the same, but the acceleration is the same. Okay, the acceleration is the same. Different objects with different masses accelerate to the ground at the same rate. However, they don't hit the ground with the same force. Newton's third law is for every action force, there's an equal and opposite reaction force. According to Newton's third law, whenever two objects interact, they exert forces on each other. When you sit in the chair, you exert a downward force on the chair exerts an upward force on you. That's a force pair. Same thing every time you touch a keyboard. Think about on the way to school, the wheels spin forward, they grip the road, push the road backward, makes the car go forward. And when you were a little kid, your teacher saying the wheels on the bus go round and round, and the motion that went with that actually showed what happened because the wheels went round and round. Rockets are the same thing. You apply a downward force on the ground, and the ground applies an upward force on the rocket, giving it lift, causing it to lift off. So, hope this is a good review of Newton's first, second, and third laws, or 3 laws of motion. Thanks for watching.